If you were to take all the dust in your home right now and just sweep it into a pile and put it under a microscope,
Oh, this is such a gross fact.
it really is. Roughly half of what you'd be looking at is a graveyard of your own dead cells.
Right.
I mean, you are quite literally constantly falling apart. Yet the biological machine that's replacing those cells every single second is stronger than concrete.
Yeah, and it regulates its own temperature with, like, pinpoint precision.
Exactly. And it's capable of generating 22 tons of mechanical force. So, welcome to the deep dive.
It really is a profound contradiction, you know? We constantly experience our physical vulnerabilities, like a paper cut stings.
Oh, yeah.
Yeah.
Or a bad night's sleep leaves your neck aching for days.
Right, exactly. We feel incredibly fragile. But beneath that perception is an absolute masterclass in organic engineering.
Which is exactly what we are unpacking today. The subject isn't, some complex geopolitical issue or a new tech gadget.
Yeah.
The subject today is you, the listener. We are taking a deep dive into some absolutely wild material from DK Publishing's Super Human Encyclopedia.
Such a great source.
It really is. And our mission here is to fundamentally shift how you view your own physical form. We want to move away from this idea of like a delicate meat sack to really understanding the bizarre, hyper-adaptable, organic machine you're currently piloting.
I've been so looking forward to this because what jumps out from the data isn't just the sheer scale of the numbers.
Though they are massive.
Oh, they are. But it is the ruthless efficiency behind them. We are talking about microscopic rules governing overwhelmingly powerful systems.
Let's actually start with that scale, looking at humanity through the absolute widest lens possible. When we think of our global footprint, we usually picture cities spreading out.
Right, or carbon emissions, agriculture, that sort of thing.
Exactly. But just the raw biological mass of humanity is staggering. If you took all the humans currently on Earth and somehow put us all on a giant scale, our collective physical weight is about 300 million tons.
Which is a number so large it almost like loses its meaning.
It does.
To visualize it, imagine the Empire State Building.
Right.
Now imagine 800 Empire State Buildings stacked up, kit entirely of human biology.
That is just, it's deeply unsettling.
Right.
And completely awe-inspiring at the same time.
Yeah.
That is our collective physical weight on this planet. And that mass is relentlessly expanding.
Yeah, constantly.
We are adding to that weight with roughly 250 babies being born every single minute across the globe.
The fun fact, the single year the most humans were born was actually way back in 1963.
Really? 1963?
Yeah, the peak of the baby boom. But 250 a minute today is still a massive growth rate.
Wow. But what I really want to zero in on is how we managed to get to that scale. Because it isn't just that we breed quickly, We dominate the planet because our bodies literally alter themselves based on the environment.
Yeah, the adaptability of the human framework is, arguably our most impressive feature.
See, I have to push back on that a little, or at least how we frame it.
Okay, how so?
Because when we talk about human survival, we usually credit our brains.
Right.
We credit our software, We survive freezing climates because we invented thermal jackets.
Right, and built insulated houses.
Exactly.
Yeah.
We explore the oceans because we engineered scuba gear.
Mm-hmm.
But you're saying the physical hardware itself is actively changing. I always thought evolution took hundreds of thousands of years.
It's a fair point. It's true that the brain and the technology it creates is our primary survival mechanism, but the flesh and blood framework beneath your neck does not just sit stagnant waiting for evolution to catch up millennia from now.
Okay.
It is constantly running optimizations in real time. Think about populations that have lived at high mountain altitudes for generations.
Like in the Himalayas or the Andes.
Exactly. They don't just acclimate to the thin air by breathing heavier. Their physical architecture actually changes. They develop broader chests and physically larger lungs to increase oxygen intake.
Mm-hmm.
And internally, their bodies manufacture a permanently higher concentration of red blood cells, just to aggressively pull every available molecule of oxygen out of that super thin air.
So the hardware literally molds to the geography.
Yep. And the same thing happens in extreme cold climates. People indigenous to polar regions naturally develop broad, thicker physiques.
To stay warm.
Right. And the mechanism there is fascinating. It mathematically minimizes their surface area relative to their body mass.
Oh, I see. Less surface area exposed to the freezing air means less heat escapes.
Exactly. It basically turns the human body into a highly efficient thermos.
That is wild, which proves that despite all our advanced technology, all our synthetic fabrics, our climate-controlled homes, The human species is still deeply mechanically tied to the natural world.
Completely. Our bodies are constantly analyzing the environment and pulling levers to optimize survival.
Okay, so we have this species that has grown to over 7 billion distinct individuals, right? Capable of tweaking its own hardware to survive mountain peaks and freezing tundras. But to understand how that massive 800 Empire State Building footprint actually functions, we have to zoom all the way down from the global population to the microscopic blueprint making it all happen.
Down to the cellular level, this is where the true engineering genius lies. I mean, it is humbling to remember that every single human being, for roughly the first 24 hours of their existence, is nothing but a single solitary cell.
One day of your life spent as a microscopic dot.
Just floating there.
And the sheer volume of cells you eventually multiply into is almost incomprehensible. The analogy from the source material that really helped me visualize this was a matter of scale.
Oh, the height analogy. I love this one.
Yeah. If a typical human cell were the size of a full-grown person, the whole human body surrounding it would be 62 miles tall.
62 miles?
Your head would literally be poking out into the vacuum of space.
It's just a brilliant way to conceptualize the density of information packed inside you. Because inside almost every single one of those billions of tiny cells sits the human genome.
The blueprint.
Exactly. Roughly 22,000 distinct genes packed tightly into 46 chromosomes.
And they aren't distributed evenly at all, which I found super interesting. The X chromosome holds something like 2,000 genes.
Right.
But the Y chromosome, the one determining male biological sex, holds just over 200. It's basically like a genetic pamphlet compared to a massive encyclopedia.
Yeah, it is incredibly specialized, but within this vast, strict instruction manual of DNA that governs almost every cell in your body, there is one brilliant rule-breaking anomaly.
Oh, man.
A specialized labor force that completely ditches the manual.
The red blood cells. This completely blew my mind.
That's so weird, right?
Red blood cells are the only cells in your entire body that do not contain DNA. They completely lack a nucleus, which is just baffling to me.
It goes against everything we learn in high school biology.
Exactly. The cell responsible for keeping every single other system alive by delivering oxygen is flying completely blind. No brain, no instruction manual. How does it not just immediately die?
Well, it does die, and rather quickly, actually, but that's the point. It's all about ruthless efficiency. A cell's nucleus, where the DNA is stored, acts as the command center, right? But it takes up physical space.
Okay, I see where this is going.
The red blood cell only has one vital job, and that's to carry oxygen. So by actively ejecting its own nucleus and throwing out the instruction manual, the red blood cell maximizes its internal storage space.
It's like taking a race car and ripping out the dashboard, the passenger seats, and like the air conditioning just to make it lighter and faster.
Exactly.
It hollows itself out to become the ultimate cargo ship.
That is a perfect way to put it. Because it throws away its DNA, it sacrifices any ability to repair itself or divide.
Wow.
It accepts a short, finite lifespan purely so it can carry the absolute maximum payload of oxygen to the rest of the body. It is the ultimate biological example of sacrificing self-preservation for the greater good of the entire organism.
Okay, so you have trillions of these microscopic cells.
Yeah.
Some are hollowing themselves out to transport gas. Others are building internal infrastructure. But none of that delicate, wet cellular machinery survives for more than a few seconds if it's exposed to, like, harsh UV radiation.
Or invasive bacteria.
Right. Or just a dry breeze, which is why those cells are aggressively building what is essentially a living spacesuit to seal everything inside.
The skin. You know, when we look in the mirror, the illusion of permanence is incredibly strong.
It really is.
We think our skin is a static, unchanging wrapper. We buy expensive lotions and creams to keep it exactly as it is. But what you are actually looking at is a highly disposable defensive shield.
Disposable is the key word there, because skin is the body's largest organ, and its primary defense mechanism is literally throwing itself away.
Yeah.
You shed roughly 50,000 flakes of skin every single minute, which brings us back to that unsettling dust action in the beginning.
The graveyard of dead cells.
Exactly. Half the dust settling on your bookshelves is dead human tissue.
It sounds totally gross, but think about the functional brilliance behind it. By constantly pushing new cells up from the bottom and shedding the outer layer of skin and hair, you are actively discarding dirt, germs, and microscopic parasites.
Before they have a chance to penetrate deeper.
Exactly. You are basically a self-cleaning oven.
So it's not a static brick wall keeping invaders out. It's more like a roof where the top shingles are constantly detaching and falling off.
Oh, that's a good analogy.
Right, taking the moss and dirt down with them, while fresh shingles are pushed up from underneath. And the thickness of those shingles varies wildly, like your eyelids are 1/125th of an inch thick,
Super delicate.
but the soles of your feet are a solid 16th of an inch. And the hair on that skin is temporary too.
Oh, yeah, very temporary.
The source mentioned that head hair only lives 2 to 6 years, growing about zero point 0.3 millimeters a day, which means most people's hair naturally maxes out at around 3 feet long,
Although the world record is an insane 18 feet.
which is terrifying. But normally we just lose 80 to 100 scalp hairs a day as part of that shedding process.
Right, and this spacesuit doesn't just block physical threats and shed parasites. It acts as a highly advanced automated climate control system.
The ultimate thermostat.
Yes. Deep in your brain is a tiny cluster of cells called the hypothalamus, which acts as your central thermostat.
And it is working incredibly hard to keep your core temperature in a very narrow, safe band. When you get cold, the hypothalamus triggers shivering.
Which we hate.
We do. We usually just experience shivering as this miserable, uncontrollable reaction to a winter day. But those rapid, involuntary muscle contractions are actually an engine firing up. The friction of shivering to stay warm can burn 400 calories in a single hour.
That is a massive energy expenditure just to generate heat. And in extreme heat, the system violently reverses.
Right.
To prevent your internal organs from cooking, the skin releases watery sweat to cool the surface through evaporation. Under severe heat stress, a human body can pump out up to 3 pints of sweat an hour.
3 pints an hour. You would dehydrate so incredibly fast.
You really would.
But this thermal regulation has a terrifying limitation, especially when it comes to water. Because cold water steals body heat roughly 30 times faster than cold air.
30 times?
The thermal conductivity of water just rips the heat right out of you.
Yeah.
If you plunge into freezing water, your survival time is just 10 to 20 minutes before the hypothalamus is overwhelmed and the whole system completely shuts down.
It highlights the extreme and narrow parameters our cells require to function. We really are delicate in that sense. But if we peel back that shedding, sweating spacesuit, we find a hidden scaffolding that is anything but fragile.
The skeleton. Now, pop culture and Halloween decorations have totally conditioned us to view bones as these dry, brittle, dead white sticks.
Like dusty museum props.
Exactly.
Yeah.
But the reality inside a living human body is completely counterintuitive. Your skeleton is not dead. It is a vibrant pinkish white. It is an active biological factory churning out millions of red and white blood cells inside the marrow. And this is the stat that completely threw me. Your skeleton is actually 25% water.
It is an active, wet, deeply dynamic organ.
Okay, I have to stop and unpack this.
Go for it.
Because we also know that bone is incredibly strong. A human thigh bone, the femur, can support 30 times its own weight. It is mathematically stronger than concrete.
It is.
But if my bones are a quarter water, does that mean they can dry out? Is that what osteoporosis is? Like a sponge getting brittle? How on earth can something wet be stronger than concrete? That feels physically impossible.
That is a fantastic question, and it gets right to the heart of structural engineering. You see, you are equating strength with pure rigidity.
Well, yeah.
Concrete is rigid, yes, but rigidity is brittle. If you apply enough bending force to a concrete pillar, it snaps violently, it cracks. The architectural brilliance of human bone is that it isn't a solid, rigid block of calcium.
So it's not just a heavy rock inside your leg.
Not at all. It is built much more like a honeycomb. Or if you look at the cross-section of an airplane wing,
Okay.
you have an incredibly dense, hard outer shell. That's the compact bone. But the inside is spongy bone, a complex lattice work of struts and empty spaces, all filled with marrow and those pressurized fluids.
Oh, I see.
This matrix design, combined with that 25% water content, gives the bone the ability to flex slightly under extreme physical stress. It absorbs the shock and disperses it, rather than snapping.
Oh, wow. So it's more like a modern skyscraper that's engineered to sway slightly in a windstorm or an earthquake,
Exactly.
rather than a rigid stone tower that just cracks and falls over.
Precisely. That fluid flexibility is its strength. And the scaffolding is highly modular, too. I mean, we're born with about 300 individual bones, which gradually fuse together down to 206 by adulthood. And remarkably, over half of those adult bones, 106 of them, to be exact, are located entirely in your hands and feet.
Which makes perfect sense when you think about what allowed us to survive and evolve. Fine motor control for making tools and complex foot mechanics for running and climbing. But
Exactly.
all those separate bones are just useless sticks if they can't pivot. Which brings us to joints. We have over 400 joints in the body. Surprisingly, though, about 150 of them don't actually move at all.
Like the fused tectonic plates in your skull.
Right, exactly.
Yeah.
But the joints that do move rely on another marvel of biological engineering, which is cartilage.
Oh, cartilage is amazing.
It is the shock absorber between the bones, and the friction stats on this are just wild. Cartilage is up to 80% water, and it is somewhere between 5 to 10 times more slippery than ice.
That's
We
insane.
literally have our joints sliding against each other inside our knees and elbows with significantly less friction than a hockey puck gliding on a frozen pond.
Which is vital. Without that extreme hyperlubrication, the sheer mechanical force of our daily movements would cause those wet honeycomb bones to grind themselves into dust in a matter of months. Yeah, painful. But of course, a perfectly lubricated, shock-absorbing scaffolding is completely useless on its own. It would just collapse into a pile on the floor without an engine and a pulley system to actually pull it upright.
And this is where the system gets truly magnificent, the power plant, the muscular system. This is the raw, hidden power we mentioned at the very beginning of the deep dive, and it relies entirely on microscopic teamwork.
Yeah.
We have 650 skeletal muscles in the body, making up a massive 40% of our total physical weight.
The ambient energy generated by that mass is immense. I mean, even when you are resting, just the byproduct heat generated by your muscles performing baseline functions every day is enough to boil 2 pints of water for an hour.
Just imagine a literal kettle boiling inside your chest for an hour.
It's crazy.
And that is just the ambient waste energy of your muscles existing. The active mechanical force they can generate is terrifying. The source says if all 650 muscles in the human body were somehow detached and pulled in the exact same direction at the exact same time, they would produce an astonishing 22 tons of pulling force.
22 tons. You are walking around with the mechanical capacity to lift a commercial fire truck.
Wow.
But the key word there, the fundamental rule of this biological engine, is pull.
Right. Muscles only pull. They're biologically incapable of pushing.
It is a crucial mechanical concept. When you push a heavy door open, your muscles aren't actually pushing your bones.
Right.
The muscles on the back of your arm, your triceps, are pulling the lever of your elbow straight. That straightening action is what pushes your hand forward against the door. Because they can only ever contract and pull, muscles must be arranged in opposing teams to function.
It is essentially a high-stakes, incredibly complex game of tug-of-war happening all over your body, constantly.
Yep.
If you want to bend your arm to pick up a coffee cup, your bicep pulls. To straighten it back out and put the cup down, the bicep has to relax while the tricep pulls in the exact opposite direction. And it goes so far beyond movement. If you are sitting in a chair listening to this right now, or driving a car, just maintaining a perfectly still, upright posture requires dozens of opposing teams of muscles pulling against each other in perfect harmony.
They're tying the game of tug-of-war so your spine doesn't just flop over.
Right. It is an ongoing symphony of micro-coordination. Think about the most mundane actions. It takes 8 different muscles firing in sequence just to chew a single bite of food.
Wow.
It takes 35 highly coordinated muscles in your hand and forearm to simply hold a pen and write your name. And your tongue, which we tend to think of as just a single fleshy slab, is actually an intricate, intertwined team of 8 different muscles.
Like an octopus tentacle?
Exactly. Working together to help you speak and swallow.
It's unbelievable. When you break down the mechanics like that, you realize there is absolutely no such thing as a simple movement.
Not at all.
Every time you blink, every time you shift your weight in your seat, your brain is conducting a massive orchestra of pulling forces. And if we zoom out to the macro level, looking at human performance, you can truly appreciate the extreme limits of this biological system.
Like with athletes.
Exactly. Watch elite athletes. When a long jumper leaps 5 times their own body length, or when an Olympic sprinter is literally airborne for 60% of a 100-meter dash.
Which means they are flying more than their feet are actually touching the ground.
Yes. That moment of suspension is the ultimate culmination of every single system we've discussed today.
Right.
In a fraction of a second, the brain's hypothalamus is dumping heat through sweat. The wet honeycomb bones are acting as levers to multiply force. The icy slick cartilage is preventing the joints from destroying themselves.
And hundreds of those 650 muscles are firing.
In a perfectly synchronized sequence, applying perfectly timed pulling force to launch that internal skeleton through the air.
It is genuinely staggering. I mean, we have covered a massive amount of ground today. We started by looking at the sheer 300 million ton global weight of adaptable humans, shifting our very hardware to dominate mountains and freezing poles.
Yeah.
We zoomed all the way into the microscopic cells, literally hollowing out their own DNA just to carry more oxygen. We peeled back the shedding, self-cleaning spacesuit of our skin. We examined the wet, flexible matrix of our bones sliding on that hydroplaning cartilage. And we finished with the 22-ton tug-of-war engine of our muscles.
It's a journey that fundamentally reframes our relationship with ourselves. And based on all these biological marvels we pulled from the source, I want to leave you, the listener, with one final provocative thought to mull over.
Let's hear it.
Consider the sheer incalculable computational power required to run this organic machine. Right now, you're probably just sitting there effortlessly listening to this audio, maybe watching the road if you're driving.
You feel like you were just relaxing.
But beneath your skin, a 206 bone, 650 muscle, heat-generating, self-repairing factory is executing millions of microcommands every single second.
Without you even noticing.
Exactly. It is balancing opposing muscle groups to keep you upright. It is regulating your core temperature against the ambient air. It is manufacturing millions of fresh red blood cells in your marrow, all entirely on autopilot.
Yeah.
It is performing a miracle of engineering every second, and it asks for absolutely nothing from your conscious mind other than a sandwich and a glass of water in return.
So tomorrow morning, when you wake up, look in the mirror, bleary-eyed, brushing your teeth. Do not look at a fragile, everyday meat sack. Look at the highly engineered, beautifully bizarre, adaptable machine looking back at you. Thank you so much for joining us on this deep dive into the source material. We will catch you next time.